It's my pleasure to introduce and invite Mr. Ravid Levy, a distinguished expert in water innovation and technology transfer, to share his insights with us today. Mr. Levy is a senior director at wateredge.il, where he plays a crucial role in advancing cutting edge water solutions. He holds a bachelor's degree from the Hebrew University and a master's degree from Tel Aviv University, specializing in biology and environmental sciences. With nearly 20 years of experience, he has played pivotal roles in advancing water and waste treatment solutions. His expertise lies in bridging the gap between research and real world application, ensuring that cutting edge developments are successfully transformed into practical and scalable solutions. Beyond his technical expertise, Mr. Levy is deeply committed to building a strong and collaborative water innovative ecosystem. His vision is to bring together academia, startups, established firms, water authorities, and government bodies, creating a dynamic network that accelerates progress and strengthens Israeli leadership in the water sector. Uh, we are truly grateful to you, sir, for accepting our invitation on such a short notice. Please join me in welcoming Mr. Lavi. Sir, I request you to give the lecture now.
Thank you. Thank you so much. And I guess maybe more people will join.
Yes.
Although the best part is the beginning, so they will miss the best part, maybe. Anyway, it's a pleasure being here and presenting to such a respectful and forum and organization. And I keep discovering more and more great collaboration and great organizations in India with water. So it's great to be part of this activity as well. And there's already a lot of collaboration and initiatives between Israel and India regarding water, and I think there's so many more to be established and to be discovered. And I hope that would be this today will be another small step in that direction. First, I will say a few words about what is the organization I work for. I manage wateredge.il. That's a pretty unique organization, which is a government initiative by the Israeli government, but practically working as a joint venture between the government and academia. This is, we call it the Israel Water Innovation Community, but it's basically a national, non-profit professional organization that works with all parts of the Israeli water ecosystem. We try to show here in this puzzle the different parts of the ecosystem that we are connected and working with, academia and utilities and government and different companies, both startups and established industry and NGOs, and also in the international community of water professionals. And the main purpose here is to remove some barriers and increase communication and collaboration between the different parts of the ecosystem, both within Israel and with the world. And we're trying to do that in different ways, including events, conferences, hackathons, challenge competitions, and different activities that will bring people and organizations together. The main purpose is at the end to promote and enhance adoption of innovation of all kinds into the water sector here in Israel and also between Israel and the world. This initiative or this organization operates for the past 4 years. We are practically part of the Kinneret Academic College, which is in northern Israel, but working nationally under the supervision and the guidance of the Ministry of Economy and the Israeli Water Authority and Israel Innovation Authority, all together joining forces in order to promote water innovation. So today I would like to talk a little bit about what it may not be anything new for this forum of water professionals, of how water is and must be a central part of climate resilience, both climate adaptation and mitigation, and to some extent how it is not being seen as such by a lot of climate professionals and especially investors around the world, and also a few examples of how Israel as a country has been active in promoting or adopting water strategy and technology as part of its climate resilience, although it was done way before the term climate resilience or climate change even existed. So we all know, this is no big news for anyone here, that there is an increasing water challenge around the world, in some places more than others, but practically everywhere, with increasing demand for water fit to purpose or usable water. I mean, the quantity of water is finite and does not change, but the supply of suitable water for the human consumption and use is decreasing for different reasons, droughts and heat waves, I mean climate change in general, which leads to sometimes less rain and snow in some places, in other places too much water, so floods, but that's not really usable, or even creating damages, evaporation, contamination of water sources, which is a major factor, water losses in systems and networks. On the other hand, there's an increasing demand. Population grows almost, I mean, everywhere, but in some places more than others. Modern life and the life standard and demands more and more water resources for anything we do. And the culture of consumption and prosperity all lead to higher demand of water. And there's a gap which is increasing between the demand and the supply of water globally. In general, I mean, there are different numbers. This is one that I found on a global scale. We use water for three main applications, besides, of course, nature itself, which is a user or well, must get its water, but for the human consumption, mostly for agriculture. In other words, water is practically the most important part of food security and growing food globally. We have industrial use, and that includes a major part of water in power production. Almost all types of power production requires a lot of water, but also any other industrial and manufacturing activity, and domestic use, which is partially for drinking, but mostly in many places for other domestic uses. And altogether, that creates the human footprint, if you like, on water. Now, within the water industry, again, many of you probably know that we sometimes say that all or most water challenges could be or can be divided into four main categories. It's a little simplistic, but it helps put things in categories in order to start making sense of water challenges. And these are having too much water, as in floods or land erosion. That's the mainly where it manifests itself. To not enough water, too little water, which is under droughts, aquifer level reduction, and also to a certain extent, non-revenue water and water leaks that eventually brings not enough water to the taps. Poor quality, so water quality is a major issue, and that involves every type of pollution and contamination, including salinity, disinfection issues, or bacterial, different microbiological qualities, different pollution of groundwater and surface water, and the entire world, of course, of water quality monitoring. which is a lot of technology and a lot of laboratories that are there to allow us to know what is the quality of the water that we have. And eventually, possibly one of the most important parts is water availability. I mean, having enough water at the right quality practically means nothing if we cannot make it available to the user, whatever it is, the farmer, the domestic, or the industrial, at the right cost with proper infrastructure and management. And so all these together more or less create some kind of a map of the different, or most different water challenges. And when we have some kind of a water challenge or a need, we can put it somewhere around this this map and focus our solution. Of course, some of the problems are in more than one part of the map, because as we said, management in a way, or availability, touches many other aspects as well, for example. So a few words about the impact or the significance of water in the global climate crisis. This data is taken from a GWI report about water and greenhouse gases. Sorry. And they show that more or less between 2 and 5% of emissions are coming from the water sector. About 2% of carbon emission, but about 5% of methane emission, which is, as we know, a very strong or potent greenhouse gas. So, well, some can say that this is not really a lot. I mean, 2 to 5%. There are much bigger emitters and contributors to global warming. So maybe, but on the other hand, it's not insignificant. So it's especially on the methane part. There's a lot of methane that is made or emitted from different water, especially wastewater and sludge activities. And there's also a part to the water sector and industry in mitigating climate change, or at least not promoting it more or making the problem worse. However, given these numbers, still water is seen globally more as a climate adaptation than a climate mitigation challenge. In other words, water is in many ways how climate change will manifest itself, or the problem that eventually as people will be somehow related to water. So getting ready and getting resilient to the changes in climate will in many cases involve water solutions. And a pretty good way of demonstrating that is this chart from the same report that puts the cost, or how the cost, in this case, the insurance cost of damages related to climate change, how much of that is related to water. And we can see that about 70%, if only 2 to 5% of the problem is coming from the water industry, about 70% of the results of the damages of climate change is somehow related to water. And that means, and that's quite a lot of money. Overall, they estimate about almost $2 trillion of losses, economic losses, and about 70% is related to water, one way or the other, which means that climate resilience is effectively managing water in a better way so we can avoid or minimize the losses and damages that are created by water from the changing climate, while possibly there is a lower significance or importance of the water sector in preventing or mitigating climate change in terms of reducing its emissions. Again, not saying that it's not important or negligible, but in proportion, the focus of water is more towards the resilience and avoiding the damages, or reducing the damages rather than avoiding the problem itself. Now, you would expect that these numbers will draw quite a lot of investment and focus on water solutions in order to avoid these damages, right? $1.8 trillion is quite a lot of incentive. However, this is not exactly the case. Again, Global Water Intelligence estimated that about $1 billion were raised or invested in early stage or startup and other early stage water solutions in the last year. That's 2024. I think there might be sorry. But that's in 2024. And you can also see more or less the number of those investment rounds. 136 deals, which is well, it's they say it's a record number, but it's still not a lot in global economic terms. And also it could be quite interesting to see where most money is flowing to within water. And you see that digital and AI solutions related to water, and also circular economy and some other physical interventions, which means water treatment, quality, possibly including desalination, takes about half or more than half, so the major part, and all the rest is in other places, including things that are not directly water sector related, like lithium extraction, which is more mining, but in a way related to water. So that's the picture globally, and I can only say that, at least personally, I think that if we keep on investing only about $1 billion a year in water, there's practically no way we will be able to take care of this major problem anytime soon. So something will need to be done in order to put more effort and more money into water innovation in order to allow it to avoid or to create better water resilience against changes in climate and other issues. Now, in order to show that, this is probably the most interesting chart in this respect, which shows how much, or what is the proportion that's in blue, of water and sanitation investment against other climate sectors. This is just comparing climate investment and water investment in those years, 2020 to 2023. And you see that almost anywhere, first of all, it's split between adaptation and mitigation. You can see that in absolute numbers, the investment in mitigation is way bigger than in adaptation, especially in high-income countries that practically don't really invest in adaptation, and which already says that the world has been, I'm saying has been because it may be changing now, gradually, possibly changing, but the world has been completely focused on climate mitigation and practically neglected adaptation in the past 4 or 5, or in the last decade, I dare say. And if there were some investments in adaptation, they happened in low or middle income countries rather than the rich countries of the world. And since, as we said already, that water is mainly a adaptation thing, then it's not surprising that if adaptation was practically neglected, also water investment wasn't very high. Again, that's everywhere. I mean, a little bit more around the low and middle income, but globally. Now, is that about to change? Will the world shift its attention, at least partially, from mitigation to adaptation, following the very clear signs that climate change is already happening and the big disasters and big issues happening around the world? Possibly. If that will happen, it will also probably bring more resources into the water sector, being very central to adaptation. But that's still to be seen. But the very clear message is that water is a very central part to climate change. It is mostly an adaptation issue. And as long as the world is focused on mitigation, water will not be a significant part of the focus and also resources. If adaptation becomes more central, water will also become more central to the globally. Of course, it won't be the same everywhere, but I think that's a fair statement to make, that globally the shift from this side to this side will benefit water. Now, after talking about the world or globally, let's zoom in a little bit into Israel, just as a model, as an example of a country that has been suffering or has been dealing with some of these challenges for decades. I mean, Israel is located here in the Middle East. It's a very small country, just about 22,000 square kilometers, so it's tiny compared to India and other bigger countries, with about 10 million people these days, but a pretty high population growth, the highest in the OECD or the highest in the developed world, of about 2.5% per year, and a fair or pretty high GDP per capita, which means that, and this is today, but the country is just about 75 years old. In fact, very similar to India, got independence around the same time. And the location is right on the border, really just in the middle between the desert area of the Middle East and the, let's call it the Mediterranean climate of Southern Europe, which means that within this very small area, and it's just about 600 kilometers north to south, there are few climate regions where the south or the center and the south are, everything here in yellow is practically desert, and the rest is semi-arid, mostly semi-arid, with some along the coast, of course, a little bit less, and in the north there are the majority of precipitation and also natural water resources. So the country really needed to deal with this kind of arid, semi-arid climate with growing population and economy for the past 70-something years. And also geopolitically, as you may know, Israel is pretty isolated from its neighbors. In other words, it cannot really rely on, in terms of water or any other resource, on its neighbors in any way. There are a few, some of the natural rivers, if you like, or streams are crossing the border in the north. But in practice, Israel had to create its water strategy as if it's an island. So isolated and taking care of itself. And all this together create a pretty challenging situation. So we had to develop a whole system of a legal framework and management framework, and on top of it, of course, engineering and infrastructure and technology that will allow the population to grow, the economy to grow, while water resources are limited and also not evenly distributed around the country. So basically, the framework that was created is based on, if you like, three main pillars. One is, of course, the natural water resources that we have, which is, of course, precipitation, which is mostly in the north, ground and lake water. There is just one lake in Israel, the Sea of Galilee. It's pretty large, but not huge in global terms. And again, it's located in the north, while most of the population is located in the south along the coast. There is groundwater, so few aquifers, and also flood collection. So the weather, the climate here was always very seasonal, with flash flooding and very intense rain over limited period of time. And climate change models, which means that we have to work on predicting and managing the resources according to predictions of what is going to be the precipitation and also the population growth and everything else. The other pillar, which was created in the past few decades, since natural water is limited, is what we call manufactured water. And that's basically using two unconventional water resources. One is wastewater reuse, which we will talk about a little bit later. And the other one is seawater and, to some extent, brackish water desalination. And gradually, within the last few decades, Israel invested a lot and really put desalination as a major part of its national water strategy. So it's not a curious, not just a local solution. It's a national water solution that makes up whatever is missing between demand and natural water supply. We'll see some numbers in a moment. And on top of that, practically the first pillar, actually, is integration and regulation. There's one national water grid, so the entire country is basically connected in one main water grid with a main corridor of pipelines and tunnels that can transfer water practically from anywhere to everywhere. So if originally there was more water in the north than in the center and south, where the most population and agriculture is. So we built the national water carrier to bring water from the north, from the Sea of Galilee down to the south. However, in the last few years, since desalination along the coast, mostly in the center, became more important or bigger proportion, in fact, also the national carrier direction can also be changed to transfer excess desalinated water from the center to the south, but also to the north if needed for either use in years of drought or less availability in the north, but also to store excess water from desalination in the lake, in the Sea of Galilee, in order to use it later when needed. So in fact, there's a whole managed water grid around the country. And that is, this is backed by a national operational plan, which is managed by the Water Authority, which is the national authority with the responsibility of managing the national water resources. And on top of that, there are efforts for preservation and recovery of water, long-term strategic planning, and also, depends when, but educational and community activities in order to raise awareness and save water by the population in different ways. So altogether, create some kind of one water system and one regulation and management system on a national level. Now, of course, in Israel, as we said before, it's a small country, so the national level is maybe equal to a regional level in a big country like India, but that could be a model of how a limited resource can be managed as a whole by with a central planning and a national or regional management rather than a local or private one. By the way, it's very important to stress that the very basis for this management in Israel is the water law, the Israeli water law, which was put together back in the 50s, and it defines or it states that all water resources in Israel, either above ground, below ground, dirty or clean, is owned by the public. It's practically a public domain, and the government has the authority and the responsibility of managing it for the public. In other words, there is no private water in Israel at all. All water is practically owned by the state, by the public, and managed by the water authority. They can give licenses and different allowances for different organizations or people to use or to extract or to even sell water, but all of that under one central management. And that's the basis of creating all these three pillars. There was some privatization of some water resources. For example, all desalination plants are private, but they are under a BOT agreement with the government that practically buys the water from the private company that built and operates the plant, and then sells it and delivers it and sells it to the public under or by the national water grid. Okay, so how does it look in numbers? So this is the Israeli national water sources balance, if you like, in million cubic meters per year. And you see that since in the 60s and 70s, the entire or the only water sources, and before that, of course, all water resources were natural. That's the blue lines, natural water resources. Since the 70s and 80s, there was more and more recycled water. And in Israel, recycled water means that this is domestic effluents that are treated and recycled by a separate grid of pipes to agriculture. In Israel, we recycle most of the wastewater, domestic wastewater, but only to agriculture. That is the national decision or the strategy of separating between recycled and fresh water and directing recycled water to agriculture, while fresh water and desalinated water are used mostly for domestic and other like industrial uses. And so you see that gradually, and that is really depending on natural recharge and climate, you see that the blue part, the natural part changes, and that the problem was created over here in the 90s and 2000, when in fact you see, the green line is the average natural recharge. So that's the sustainable natural water resources that we have. And you see that after the 60s, we practically used more natural water than the recharge, which means that levels of aquifers were dropping, levels in the lake was dropping. We were over pumping and overusing the natural resources. So and this is because of growing demand. So something had to be done. And the way to tackle that was to complement the demand by reused or recycled water. This is complementing the agricultural demand, irrigation, and then from the early 2000s by desalinated water to add more water to the domestic demand. And that allowed, on one hand, to increase overall water availability and resource and to meet demand. But on the other hand, as you see on the blue line, to reduce the over pumping and overuse of the natural resources and allow them to replenish, to come back, because once we could use other water sources, we could reduce the dependency and also the pressure on the limited natural water resources, which in some ways also declining due to climate change. So in a way, this is how how climate adaptation looks like. The demand grows, the natural resources declines, and we have to do something to manufacture or to supply water from other sources to balance those two things. Otherwise, that could be unsustainable. We would either have to keep on overusing the natural resources, which is limited but also very unsustainable, or to limit growth somehow or demand by whatever that may be, including economic growth. So this allowed both to happen without compromising water supply to the public. And so eventually, especially when we're looking at mostly agriculture, remember that all the South is basically a desert. And since the beginning, the vision that was set by David Ben-Gurion was, we need to green the desert. We need to grow food in the desert in order to survive. And the only way of doing that was to supply water to those areas. And in this case, mostly recycled and desalinated water. And you see in this chart that practically Israel managed to decouple the population growth and the water, or the fresh water in this case, the fresh water consumption, both because we've done a lot of efforts in reducing per capita or to save water in different ways, and we will see in a moment, reducing water leaks and losses, but also domestic and industrial and agricultural water consumption. There are many efforts of reducing it by using different technologies like drip irrigation or other efficient irrigation, like different water-saving means at the homes, which used to be compulsory in Israel to install dual flush toilets and water flow reducers in taps. And eventually, and also by, as I showed before, complementing limited fresh water by other water resources. So the population and the economy continue to grow pretty fast, while increase in water consumption also grew, but in a lower pace. And at a certain point, the per capita, if you like, or per whatever, water consumption decoupled from the population growth. And that's a very important thing to have, because you keep on growing without depleting your natural water resources further. Overall, if we look at well, we're this pride of being a startup nation, so it means that there's a lot of startups and a lot of innovation happening in Israel. You can see that part of that is gradually focusing on climate in general and water specifically. Not a lot, about 1% of water of Israeli startups are focused on water, but there's a pretty active and lively there's a pretty active ecosystem of startups, as I showed before, globally, but also in Israel. Early stage investment in these startups is a bottleneck, is a challenge, and we still need to enhance that. We look at some specific examples of areas where there's a lot of innovation and a lot of focus. So first of all, this is a very central thing in every sector, but definitely in the water sector. If you can't measure it, it's very hard to manage it. So one of the main things that we are focusing on is water losses, non-revenue water, or water leaks, which means, as you know, the gap between how much water is produced and eventually how much of that is being supplied and billed to the users, to the public, or to the end users. And we're pretty proud of the efforts that were done in Israel over decades of reducing non-revenue water and water losses, both within the domestic or the municipal sector and on the national grid overall, which is about 7 or 8% losses, which is still quite a lot, but in international comparison, it's on the top, if you like, or one of the lowest ratios of water loss. And it may be even more interesting to look at that in proportion of the population, which is, of course, a very important factor. I mean, it's very hard to compare a small country of 10 million people to a huge country of 1 billion people like India or China. But even in this comparison, Israel is located quite at the bottom of this chart. And still efforts are being done continuously to keep on reducing non-revenue water and water losses in different ways. And it's not surprising that and there are few strategies and few ways, important ways of bringing water losses down. Possibly the most important part of non-revenue water, or in fact, managing water in general, is measurement. So the water meter, the humble water meter, is, at least for me, possibly the most important part of any water management strategy. Because again, if you can't measure it, it's very, very hard to manage it. And definitely, there's almost no point talking about non-revenue water if you don't create revenue, or if you don't measure and charge for the water used. So the ability to measure accurately water on the different users and endpoints of any water system is very important. In Israel, we've advanced a lot and developed a lot of the remote monitoring, so what we call smart water meters. And by 2026, the regulation, the water authority decided that all water meters, all domestic water meters in Israel must be AMI or wireless. So there's already about, I think, 70 or 80% that is already there, with about 2 or 3 million transmitting meters already installed and working in utilities. And that's creating a huge amount of data. So in fact, this is by far the biggest network of IoT devices in the country. And it creates hundreds of millions of readings and alerts per day, all transmitted to the cloud and being available for analysis and for action. Of course, that allows the utility to save on manpower for water readings and all that, but also and obviously makes billing very relatively easy and straightforward and accurate. But it also allows real-time water leaks detection. And me personally, I already received several times a call from my water utility saying, we identify that you have unusual water use from your transmitting meter. Check your home or your garden and see if you have a water leak or a tap open. And it detects it very accurately. So the very basic layer of reducing water losses is knowing in real time what's happening and what's the consumption. And also the ability to charge for the consumption gives the incentive for everyone actually to save water or to locate water leaks early. We see here again from GWI some examples of how different countries, this is more the global perspective of AMI water meters, of how different countries are planning or already working at deploying them around each country, not only small countries like Israel, but China, Australia, all around Europe and the US. And you see that there is a growing, or at least plans to grow the deployment of AMI meters to the in many countries, from relatively small part of the systems to the major part, at least more than half or even the majority in some cases of the networks. As I said, Israel is not in this chart, but it's practically already starting from around here and aiming towards 100% within the next couple of years. So that's the very first layer and a very important part of knowing what's happening and preventing water losses. Another very important part is pressure and flow management in the system, in the domestic system especially. So practically, active pressure management, and of course flow management, but pressure management is a crucial part in reducing water losses, both in order to prevent water hammers and air gaps in water networks, but also at the end, the quantity of water which is being lost through a leak or a break is a function of the water pressure. So actively managing, and again with data management and these days with cloud computing and remote sensing of pressures and flows, that allows to make sure that the water system is managed on a better way. by the way, also saving a lot of energy, which is at the end a major part of the cost, but also a major part of the emissions from any water network. So flow control or water measurement and pressure control are the two basic layers. Now, on top of that, we can add different technologies for leak detection and leak repair if they already happen. This is not instead of, this is another layer, maybe, you know, the cherry on the cake of water loss management. After you know how much is being used and you manage the pressures properly, then there are always still breaks and leaks and other problems within water networks, especially underground. And identifying them early or even before they happen as a predictive maintenance, and then fixing them quickly is the difference between high percent to low percent of water losses. And these are just few examples of Israeli companies and startups that invented or developed water loss and water leak detection and repair. We can see an example for acoustic identification of water leaks, satellite vision of water in the ground and identifying possible hotspots for leaks on a larger scale. Some mini submarines that travel through the pipes with cameras and sensors and identify very small leaks just before they become a major issue. And also a system for identification, but also repair, on-site repair of leaks underground without digging and without too much infrastructure work, in order to, again, fix minor leaks before they become a big issue and a big break in pipes. So all these are examples for innovation in non-revenue water. That all, in this case, all Israeli companies that developed this here, again, as part of the national effort and the incentives of minimizing water leaks, and now they work globally, of course. And a final example of innovation that is now starting to happen regarding also water leaks and water losses is focusing on the assets themselves, not only on the national and domestic grid, on the utility level, but also on the building or asset level. We all know that water damages and water losses sometimes happen within the building, or as we say, downstream of the meter. And that's a major issue for homeowners and asset managers, and also for their insurance companies. So there are several companies, few from Israel, that developed an intelligent AI and cloud-based system for detecting leaks within the building. That could be a school or a hospital or a private home or an office building, and managing it, alerting, and also preventing or shutting down automatically the water when they identify leaks. And that's another way of looking at water loss prevention after the meter. Few words about reuse. As I said before, reuse is a major thing in Israel, but also globally. You can see here the trend of increasing water reuse globally, and gradually in some places water reuse become a significant part, a more significant part of water strategy and water supply. You can see the split here between different wastewater treatment technologies. We won't dive into that, but that's a global perspective. In Israel, again, we are very proud after many years of efforts of being able to recycle about almost 90% of all domestic wastewater. So almost all domestic wastewater is being collected, treated, and then reused for agriculture. And this is just a comparison between Israel and other countries. Of course, yes, there are different countries with much bigger area and population in some cases, but Israel in a way sets a bar of strategically aiming for reuse of all its domestic effluents for agriculture. And in fact, this is a very major part of Israeli agriculture and food security. So about 50% of all irrigation water in agriculture in Israel comes from domestic effluents reuse. So in fact, Israeli agriculture also quite depends on the ability to supply this water on top of or in addition to the limited fresh water. It's also cheaper because the other sources of water, especially desalinated, is quite expensive. So in a way, there's a win-win situation here because we can avoid dumping effluents to the environment, to the sea or to the rivers, and the agriculture can survive and can thrive actually on other or alternative water sources. This is just an attempt to show the different steps along the ladder of human circular water economy or use, from the point where we practically dumped untreated wastewater as it is to the environment, through the stage of treating it before dumping it, and then to realizing that water is a limited resource, so we can actually, if we already treat the water, we might as well use it once again. This is more or less where Israel is now. And then in the future, hopefully, also realizing that in that wastewater, there are other resources that could be recycled and reused, including biosolids, energy, nutrients, possibly other things besides water. And then we can possibly reach full circularity around our water system. Now, finally, just again, if you collect and recycle all your wastewater, it's very important to agriculture or to any sensitive use. It is very important to make sure that it doesn't include any substances or pollutants that are not degradable or then will remain there and could be toxic or could be harmful for either the agriculture or humans. So, and since there is always some industrial and other sources of effluents and pollution that is going into the domestic system, it is also very important to detect them early. So again, this need created the solution of what we call sewer surveillance. And there's an Israeli startup that specializes and now works globally on detecting anomalies or detecting unusual pollution within the domestic sewer system before it gets to the treatment plant. And then identifying those sources of unusual pollution and allowing the authorities to take action, both practical action or legal action, or just to make sure that the treatment plant is protected from industrial, mainly industrial or other unregulated discharges. in fact, this ability or the fact that they are already, or they have analytical, points around the sewer system allowed it also to be used during COVID to detect pathogens early in the sewer system as an indication for disease spread, and also assisting public health authorities in identifying and isolating COVID hotspots. So in fact, this is a good example of looking not only at the water system, the water network, as a source of data and information for better management, but also at the sewer system as a source of information. And there's a lot of data hidden within the sewer system that could be used for different benefits. That's it. So just to conclude, there are many other examples, but just to conclude, in face of climate change, we must enhance water resilience, and innovation is the only way to actually achieve these targets and make water a significant part of our climate strategy. And that's mostly what I had to share today. And happy to take any comments or questions.
Thank you so much, sir, for a wonderful talk. So I welcome participants. If there is any questions, you could ask.
There are 2 questions posted, Chaitanya. Maybe we could look at them.
Yeah, that's
the chat box.
Okay. Okay. Are these programs available for Indian water technology product companies to find pilot opportunities and in Israel and Middle East? Yes, I think for sure. There are few binational programs between Israel and India exactly for this purpose, both for the Indian market, but I guess also for the Israeli market. As I said, it's a very small market. So, the entire Israel is practically equal, maybe a neighborhood in Mumbai. But still, it's a very good testing ground and a very good pilot, if you like, place to integrate technology into an existing system that, as I said, already operates and works quite well. Of course, there are many gaps. So yes, I think the answer is yes, of course. Is stored in lakes recharged groundwater, which could lead to, correct. This water is only allowed to be used indirectly for irrigation. In Israel, is recycled water supplied directly to farms for irrigation? What are the parameters checked to ensure water quality is suitable for irrigation, taking into consideration emerging contaminants? Wow. Yes, that's a very, very important question. So in Israel, there are different standards for the quality of recycled water that is allowed to be used in different cases. And there are different levels of quality which is created or that are available from different treatment plants. There are, we define it as secondary, tertiary, and beyond tertiary quality. And each one, there is a set of parameters, many parameters that are set as the baseline for allowing that water to be used. And then the regulation defines which crops, type of crops, and also what kind of irrigation method can be used with each quality. It's a little bit complex, but this is there to ensure that the public health is being maintained. In other words, for example, if you have, say, only secondary effluents, then you would not be allowed to use it for edible crops. So in that case, only for maybe fodder or cotton or other things, and also and only in drip irrigation, even surface drip irrigation, in order to prevent any risk of disease spreading or stuff like that. On the other extreme, if you have from in the area that not all kind of water is available everywhere, but if you have tertiary or beyond tertiary quality, that is allowed to be used even on edible or green leaf or vegetables, because the quality is higher. Emerging contaminants, that's an issue that is emerging. So the regulation is not fully aligned yet with all of those, and this is developing hand in hand or together with developing the treatment trains and the treatment technologies in the treatment plants in order to meet those requirements. Obviously, there's a cost issue associated because eventually the farmers have limited ability and willingness to pay for the water. So there needs to be a very delicate balance between the quality and the cost associated with it and how much the farmers can and will be able to pay for that water against fresh water, for example. And there's a system of balancing the cost between the different users with sometimes kind of a cross subsidy between, say, domestic users and agricultural users in order to keep cost reasonable especially for farmers. I hope it answered. It's a little complex in terms of the management system there, but it's all managed on the national level. That's another important thing. The water authority is practically also responsible for water pricing and together with the health ministry responsible for water quality regulation. Okay. So they need to, it's the same body that kind of takes both into account and it has to balance between the two.
So there is one more question.
Yes, sorry.
Yeah, there is one more question from Mr. Bala. So in the chat box. Where can we find the technical details of wastewater treatment plant technologies used in Israel?
Basically on the Water Authority website. I'm not sure, it's definitely available in Hebrew, but I think they also have an English portion for that. In general terms, all wastewater is treated biologically. So up to a secondary treatment of, conventional biological treatment. In some treatment plants, or in most treatment plants, they have tertiary filtration, usually sand filters. But gradually, we have also more and more membrane treatment, either MBR or UF filtration after the secondary treatment. And in one major treatment plant, there is secondary treatment and then soil aquifer treatment, which is letting the treated water trickle into a sandy aquifer and then pumping it back after it's gone through significant natural soil treatment. And that's the highest quality, basically, at the end. This is almost equal to drinking water after it's been pumped back. However, only used for agriculture, still for safety reasons. But this is the water which is allowed for unlimited irrigation, if you like. So that's what I meant, that each location and treatment plant has a different quality depending on the technology, and the water use is also accordingly. Okay.
Okay. I think Mr.
There's a
Adarwa.
question about desalination here, which is interesting. What is the rationale for the desalination water into the Kinneret project? Yes. So this is what we call the reverse national water carrier. As I said, initially, the water carrier was built to take water from the Kinneret, from the Sea of Galilee, and supplying it to the center. And that was historic since the 60s. And in the last 2 decades, since there's more and more desalination plants, then in some parts of the year, in some seasons, well, desalination plants are best operated in a more or less stable capacity. Not identical, but it's much more efficient to operate them continuously. And also, all the desalination plants are operated by private companies under a build, own, and operate contract with the state for 25 years. So there's a minimum capacity that the state is committed to purchase from the desalination plants. Now, in summer, of course, there's a high demand for water. So all desalinated water is being used by the public almost as they are being made or produced. But in winter, there is sometimes excess desalinated water compared to the momentary demand. So this excess water can be stored, or if there's a good way to store it, then in summer we can use that excess water back, right? And so the Kinneret, the Sea of Galilee, is a great natural storage lake. And so during winter, there's a possibility to direct excess desalinated water back or down to the lake, which both enhances its water level together with rains and natural flows. But that water is then available a few months later when there's no rain to be used back and pumped back to the normal carrier. So in a way, that's another layer of looking at the entire national water grid, including the lake, as an operational system that can balance demand and supply in different times. Right?
Yeah. I think Mr. Adarwa has a question. So could you unmute and ask?
Thank you. First of all, thank you, Mr. Ravid, for this wonderful presentation. I'm Atharva, undergraduate at IIT Madras, from the Civil Engineering Department. I had a couple of questions. So, first of it, you answered more or less about the treatment, but could you give a sense of the cost comparison of the natural water, the treated water, and the desalinated water, and how do you, like I know it may vary depending upon the end use.
Yes, of course, cost is a very important aspect. So it is common to think that desalinated water is very expensive, and it is more expensive than natural water. However, at least in Israel, over the years, there's been a huge effort of reducing the cost of desalinated water. And that was done both by technology, so improving and developing desalination technologies and methods that will reduce especially energy use, which is the major part of the cost. Also, it was very important that energy it used to be very expensive in Israel. Now, because we found natural gas resources in the sea, there is better cost for producing power for the desalination plants. But also another way of doing that was to make desalination plants very big, so economy of scale, and also under this 25 years BOT arrangement, which is backed by the government, therefore allowing good financing and lower risk, financial risk for the developers. So altogether, that include, and on top of that, a very competitive system of bidding for those things. And altogether, we reached a state where the cost of desalinated water is somewhere around 50 US cents per cubic meter at the gate, if you like, of the desalination plant, which is practically or almost the cheapest in the world that was achieved. And now this is still more expensive than natural water, which I cannot really say how much, but and also recycled water, which is lower. But overall, it allowed desalinated water to be a real significant part of the overall mix without adding too much burden on the national economy, if you like, or on the water user. I know these prices, possibly in India or in other places, seem to be expensive, of course, and it's not always the same. It could not be the same solution everywhere. But the point is, the really important thing to remember is that we just didn't have a choice. I mean, of course, if you have enough natural sources, why desalinate? But as I showed before, already at the 90s, we got to a situation where the gap between natural resources and demand and population growth was just unsustainable. So there was a difficult decision of investing in desalination, but in fact, it was the only option we could make at the time. And now everybody's very happy because there's no lack of water, but it's not a miracle. It's a result of 20 or almost 30 years of investing a lot in producing more expensive water, of course. Yes.
So that brings me to another question is, I remember you showed a graph of the decades versus the usage, recycled water, natural water, and salinated water, and
Yes.
the recharge that you highlighted as the boundary above which you should not use a natural. So how do any other country establish it for their particular?
A good question. I mean, hydrologists, I think their profession is to define what is the natural recharge and what is the sustainable level of depletion compared to the natural recharge. Of course, it's not the same every year. It's an average. It's never a straight line. So it goes around a certain range. Now, in fact, it's not always exactly the natural precipitation, because in some cases, at least now in Israel, we find that at least along the coast where the majority of population is, gradually the construction, the roads and the concrete and all construction reduces natural precipitation into the ground. So in fact, due to climate change, we get more precipitation along the coast in the last few years, but we also get much more floods and flash flooding and also loss of much of that water into the sea, because there are less open areas for the more water to recharge the aquifers. So in a way, it's a balance, or it's a combination between how much natural water resource you get which is, is like force majeure, right? That's the climate and that you have, but also the infrastructure and the physical and the abilities of that water to be stored. That could be underground or above ground or in different ways, and that's part of the strategy. So yes, collecting more natural water is the first thing to do, of course, before you start desalinating and producing expensive water, but also that is limited in some cases.
Yeah, thank you. I'll just conclude with my last question, which is on whether, if we consider any treatment system, usually it is located at the downstream of any city so that the wastewater flows by gravity. I'm talking about domestic wastewater. So and then if you treat it, you may have to pump it back again to the top to supply. So what do you suggest? Should a city like Mumbai or any other tier 2 city, should they go for a decentralized treatment where but they don't have any place in the city to have a decentralized plant, or do they go for a centralized treatment? Which one is
that's a big dilemma always of centralized versus decentralized. The Israeli strategy is centralized, period. I mean, that's the way it's been done on a national level, and in fact these days even more, they are shutting down medium or small treatment plants and concentrating more into fewer, bigger plants. This is both because of cost, I guess, economy of scale, but also because it's easier, I think, to control and monitor and manage bigger plants than many smaller ones. That's the advantage of centralization. Of course, doing that requires a pretty big network of delivering both raw wastewater and treated water to and from the centralized plants from everywhere, from the different producers and then also users of the recycled water. And that requires a lot of piping infrastructure. And then, yes, that's the main reason why decentralization is a good thing. There are better ways of treating wastewater locally on a decentralized way. The technologies that used to be available only or mostly on large scale are now also being reduced or redeveloped to fit local or small scale. And then also the question is what happens with the treated water. I mean, if you have a local, if reuse is the way you want to go. So in the cities, it might be more difficult because there are less need for recycled water. Again, if we stick to the Israeli way of only using it for agriculture or maybe gardening, that's the only two uses that are allowed in Israel, depending on the level of treatment. You know that in other countries, like in California, in Singapore, in Australia, they take recycled water all the way to drinking. In other places, industry is a good way of reusing water rather than supplying fresh water for, I don't know, cooling towers or boilers or whatever that may be. So depending on the destination, decentralized solutions could be a very good thing, but there are some risks involved in that. And I think also, this is my personal opinion, that the development of better measurement, analysis and control means like remote control and IoT devices for controlling the operation of treatment plants will allow the authorities to trust or to make sure that many decentralized plants are operated over time at high level similar to the few bigger ones. Because look, even if it's very easy to design and build a decentralized plant, they still need to be operated over time. Otherwise, they will not really function, and the quality and the efficiency will not be as it's designed to be. And making sure that, you know, take, I don't know, thousands or hundreds of small plants are operated at all time according to a certain quality is not an easy task. It's much easier to make sure that 4 big plants are doing that, you know, with their dedicated staff, with their engineers, and with their expensive analytical equipment. So this, some people call it water treatment democratization, right? Kind of distributing it, but then also operating and knowing what's happening in real time. It's possible.
Yeah, thank you
Yeah.
for answering the question. Yeah.
Thank you, Adava.
Right.
And there is one more question, actually, it's in the chat box. So they were talking about the wastewater treatment plants will be major source for microplastics. So what was their management? Does Israeli has something technology for microplastics?
Yes, like emerging contaminants or micropollutants.
Yes.
This is a good example of how regulation lags behind the need or the
Right.
awareness, but and also the technology. So it's on the agenda, but it's still not regulated as a compulsory thing. The authorities, I know, are aware of that, just like micropollutants and others. The assumption, at least, is that better treatment technologies like membranes, like soil aquifer, like, I don't know, AOP and other means that anyway develop for other contaminants will also be useful for microplastics and others, but it needs more research and more verification. For sure, in terms of both, the main challenge is to reduce it at the source rather than treating it, you know, at the back. Of course, neither will work without the other in this case, but everything we reduce at the source, we will not have to invest in treating it after it's being blended and I don't know, combined in a big stream of water. It goes with, I guess, with both regulation and education and maybe some other means. It's probably the future or the biggest challenge to deal with. Again, taking into account that very important question before about the cost. I mean, the technology is there.
Right.
The question is, who will pay for all that, and how is it balanced with the risks? Yes.
You're right. And there is one more question from Mr. Krishnan, our HR. So he's written like this. So I presume you have visited India. Is there a single observation you can make on the way we use water? So that was his question.
Can make on the way we use water. I must say I visited India not enough to make any clear observation, to be honest. Well, it's a big question. The way we use water, well, of course, India has major challenges of, I think, supplying basic water services to all its population. I mean, I brought the Israeli situation, and at least here, it goes without saying that every home, everywhere, every tap has drinking water flowing at high quality 24/7. Now, I know it's not the case in India. And so before talking about all these fancy technologies, the very basics, I guess, needs to be achieved. However, I think in that respect, India, or maybe even other countries, now have both the opportunity but also the challenge of not going through all the stages of developing their water resources step by step like we've done or done in other places. It shouldn't take another 75 or 80 or 100 years to get from the India stage to, say, the Israel situation. The technology in some cases can allow some significant shortcuts. Shortcuts is usually a bad thing, but I mean in the good way of jumping, from current state to state of the art much faster. I mean, take for example water measurement, water metering. Here in Israel, every user was metered forever, but it was mechanical meters that people had to read manually, and then upgraded to drive-by that, they transmit, but then you still need to go nearby and collect the data. And now they're shifting everything to remote cloud-based sensors, right? So if in India, and I guess this is the case, there's not a lot of metering, so many users are not being metered in many places. There's no reason to go through all these stages. You should probably go directly to the high-end transmitting meters and just, if you like, jump directly to the 21st century and skip all those things in the middle, and then you can already have the data and you can already get the benefits of using it. That's just one example. That is the same in other cases. So if you're already installing a centralized or decentralized treatment plant, don't build it. I wouldn't build it as secondary and then later decide and like we do here, debate if we go tertiary like this, or we don't go tertiary, or we go with membrane, or we treat with micropollutants. It's, of course, it's higher investment to begin with, but I would, from the beginning, go to reuse quality if there's nothing. It may be a little bit naive, but learning from other countries' mistakes rather than repeating them, I think, is the most efficient thing to do. If you like.
Yeah. Thank you, sir. Thank you so much for your thoughts. Any other questions from the audience? I think
no, I think we have run out of time.
Yes,
also,
sir.
Chaitanya, I think
Yeah, sir.
thank
Yeah.
you, Dr.
Yeah.
Ravid, for an excellent discourse and active participation from the audience as well. We hope to
Yes.
reconnect with you soon. We have an
Yes.
ongoing relationship with the embassy and the government of Israel, as you're aware, and we look forward to welcoming you sometime in India to help us solve some of our
really
problems.
look forward to that.
Yeah.
Thank you so much
Thank
for having
Thank
me,
you.
and thanks for all the questions. It was very interesting. And really, just to conclude, I think there's so much potential of doing things together for the benefits of both sides, of both parts. I mean,
Yeah. Yeah.
so, yeah, let's just
Yeah.
do it.
Thank you, sir. Thank you so much. Your vision
Thank
on
you all.
water innovation is truly inspiring, and
Yes.
it was an honor having you with us today. Thank you so much, and thank you for all the participants. And we'll look forward for many collaborations.
Me too. Thank you so much. Bye-bye.
Thank
Thank
you.
you.
Thank
Thank
you.
you,
Thank
everyone.
you.
Bye.
Bye.